So, hello. Yeah, my name is Thomas Glaner, and I want to talk about joint acoustic unit and word discovery, which basically means I want to feedback word information into the acoustic unit discovery to improve it. In order to do that, I first have to talk about the word discovery model we used for that. And it's based on the word segmentation approach from Daichi. In our case, it uses a lattice input. So imagine first we have a character lattice, and this is the best path taken from this lattice, and this is given. And our goal is to recover from the lattice the correct segmentation and with corrected errors. But in our setup, we use acoustic units instead of characters. I only use characters because they are easier to write down in this case. Our vocabulary is completely unknown. The vocabulary size is completely unknown. We don't have a lexicon, and we currently don't do any initialization with text data. So we only rely on the acoustic unit input. So how do we do that? Let's say we have a lattice at the input, and the output should be a word sequence with word boundaries. And so our goal is to segment this lattice into a sequence of words. And what we exploit is basically that inside this lattice, the variability inside a word should be lower than at the word boundaries. And we also exploit that this lattice should somehow, somewhere, include the right path. It might not be the best path, but it should be included in the lattice. And so our approach is to iteratively alternate between the word segmentation. So when we have this lattice, we extract the word segmentation out of it. We're able to pass the words in the word segmentation, add them to the language model and the lexicon, and with this improved language model and lexicon, we're able to reweight the lattice, redo the word segmentation, extract new words, remove the old words first, add the new words to the language model. And so from iteration to iteration, everything should improve, and finally we should converge to something that is able to learn to do correct word segmentations. In order to do that, we need a language model which is able to learn, and therefore we use a nested hierarchical Pittman-Yor language model. So I explain first what a hierarchical Pittman-Yor language model is. Basically, it is a Bayesian approach to an interpolated n-gram language model with backoff. So imagine we start with a 0-gram, so all words are equally probable. Then we vary around this distribution to obtain a unigram distribution. And we have two parameters. One parameter is the theta, which is a concentration parameter, and it governs the variance around the base distribution. But if we only have this theta, we end up with a Dirichlet process, and we know that this process doesn't match word distributions. So we incorporate another parameter, which is a discount parameter, and this actually gives us a zip-floor distribution. So when we have the unigram, we use this unigram probability model to obtain a bigram probability model by varying around this, and again, obtain a trigram probability model by varying around this. There's a nice inference scheme on that, which uses Gibbs sampling. It's called the Chinese restaurant process, and when we undergo this inference process, we end up with a probability measure over there, and it's basically, if anybody has ever seen a Nizanai interpolated language model, it's basically the same, but we are able, with the Bayesian procedure, to actually make sense of the parameters and to learn it. This is not able to learn words yet, because we started with a 0-gram distribution, which has to incorporate the number of words. But an idea to improve this is actually Daichi's idea, is to put a unit level language model below everything. And this unit level language model is able to weigh sequences of units. And the basic idea is that the units form words. So when I want to have a starting point for my word probability, I use the probability or the likelihood of the sequence of units that are in the word. And because I'm able to use a lot of units to recombine them towards the vocabulary which this model is able to learn is actually infinite. The vocabulary size this model is able to learn. So, with this idea, why should we feedback word level information to the acoustic unit discovery? So, with this system, there were already experiments done on a phoneme lattice. It was done on a monophone HMM-GMM phoneme recognizer, which had an initial phoneme error rate of 33%. And after the word segmentation and reweighting the lattices, the system was actually able to reduce this phoneme error rate to 27%. So the phoneme error rate is reduced, and if the acoustic unit discovery uses this result to improve itself, we should see an improvement. So, what is our setup? Basically, we take the acoustic unit discovery. This delivers lattices. We do a word segmentation and a word discovery on it. The result is I have a string of segmented words, and I can use this string of segmented words to learn a unit level language model and perform a lattice rescoring with it. And afterwards, I can extract the best path from this lattice. And actually, Luca already told you about that when he talked about the phonotactic bigram language model he used. So with this interface, we are able to get the word level information into the acoustic unit discovery. So let's talk about some preliminary results. My first results incorporates only the word segmentation result, and we tried to complete the loop, but we had a flaw in the experimental setup, so we were not able to do a retraining. We only performed a topic ID classification experiment on the output of the word segmentation. For this experiment, we used bottleneck features based on the Babel corpus on the Wall Street Journal database, and we were able to actually improve the baseline to better accuracy, and we actually see that the higher the language model order of the units, the better our accuracy. So, what about the rescored lattices? I try to be upfront about it. It's currently broken. The result for that is that we need to include the word boundaries into the lattices, and we need to get rid of them afterwards because the acoustic unit discovery doesn't know anything about word boundaries. And this process is currently flawed, so I don't have any useful results about that. And this finishes my talk. Oh no, I have a conclusion. Okay, my conclusion is actually that our feedback loop is complete, but it requires some more work. We are actually able to use word level information to improve the measures, so we should follow this path. And what we haven't incorporated yet in any ways is that we could initialize the word level language model, but this requires a translation from acoustic units to characters, and this is something Mirko will talk about.